In this lecture, we are going to learn about tree successor. Okay, so we want to know which node is the successor of a given node in a binary search tree. So let's look at the problem. First, little bit recap about what is binary search tree for those who don't know. So binary search tree is a binary tree in which if X is a node in the binary search tree and if Y is a node that is in the left subtree of X, then the key of Y will always be less than equal to X. Okay. So if we have a node here 6 and anything in the left of it should be less than equal to 6. So anything in this part of the subtree should be less than 6. If we have 15 here, anything on the right of this should be greater than 15. So 16, 18, 25 all are greater than equal to 15. So this is a small definition of binary search tree. Next, we want to find the tree successor of a given node. So tree successor means what? Like if this is the 6, the value of this node is 6 and we want to find its successor, then we must find which is the node in the given binary search tree which is just higher than this 6. Okay, so that's what you need to find. So in this one we see for 6 the next higher value in BST is 7. So you have to find that. So for example, what will be the tree successor of 15? So let's see with some examples. So if X has right, so how we find out? So successor of 15, if I ask you what is the successor of node 15 here, so what is its successor? So if we see, so by definition of binary search tree, anything in the left subtree will be smaller than this. So we can never get a successor in the left subtree. So we must look into the right subtree. So here now successor means what? Just the value which is just higher than 15. So what should we do? We must find in this right subtree whichever is the minimum value that will be the successor of 15. Why? Because in the right subtree everything is greater than 15, greater than equal to 15 based on the definition of binary search tree. But we want the successor, it means that just the next element which is higher than that. So if you find the smallest element in the right subtree, then it will be the successor. So if X has a right child or right subtree, find the smallest element in the right subtree. So now you will ask how to find the smallest element in a given subtree. So just from the root, keep on traversing towards the left till you hit a node which has no left child. So that will be the smallest child in a given subtree. So we find that. Okay. Next, let's see the successor of 13. 13. What happens here? It has no right child. Okay. So how will we find the successor? Big question. I have no right child. It means I have none of the values greater than 13. Is it? Or is it not? So if you see, yes, of course, here we have no child. So here you cannot find anything greater than 13. But still there are elements 17, 18, 20, 15 which are greater than 13. So how to find successor of a given node which has no right subtree? So what we do? Keep on traversing its parent 7. So 13 is we see that it's 13 is the right child of 7. So it means of course 13 will be greater than 7. Then we come to this 7 is right child of 6. So 7 is also, it should be greater than 6. We come to 6. Recursively I am traversing my parents. So 6, I come to 6. Now 6 is the left child of 15. It means 6 will be lesser than equal to its parent. So I have found one node 15 which is now greater than 6, and in fact it will be greater than any of the children of 6, because now what happens, it is a this is 6 is the left child of 15. So this is the first node which will be greater than this 13, and hence it will become the successor of 13. So if no right subtree, move up towards the ancestors till ancestor node becomes the left child. So at 13 I went to 7, 7 is still the right child. I went to, so 13 is the right child of 7. Okay, 7 I move, then 7 is the right child of 6. 6 I move, 6 is now the left child of 15. So pick up 15, that will be your successor. Okay, so now about the code. Okay, so this is a recursive code in binary search tree, recursive code. So let's try to see BST successor of a given node X. So what we do, if right child of the node X, okay, so let's see, if the right child of X is not null, then what happens, we have a right subtree. Okay, so we have a right subtree, like here if we want to find the successor of 6, so 6 has a right subtree because 7 is the right child of it. So in this subtree I find the minimum value, so which will be 7 itself. Okay, or if for 15 it has a right subtree, so its successor will be minimum value in the right subtree, which is 17. So if it has a right subtree, then just find the minimum in that right subtree. Okay, and for finding the minimum, just keep on going towards the left child till that node hasn't got any left child. So this gives us, if it is a right subtree, then we will find the minimum from that. Otherwise what happens, what should we do? So we now have one more variable y which stores the parent of x. Okay, so this is for this case. I have to find for 13 it has no right child, so I have, this is x, this one becomes y. So in y I store the parent of x. Then what happens, if x is the right child of y, then I'm not done. I have not found a successor, because y value will be greater than x value will be greater than y, and I have not found the successor. So I now what I do, let's see in the code. So x, so while y is not null and x is the right child of y, so what I do, I make x is equal to y. So I make x is equal to y and y is equal to parent of x. So y is equal to parent of x. So this p is basically here parent of y. Okay, so here what happens, so this becomes y, which is the parent of x or y. So now I come here, then again I check in the while loop, is x the right child of y and y is not null? So yes, it is true. So I make x is equal to y, x also comes here, and y is the parent of y. So y comes here. Now y is not null and x is not the right child of y. So this while loop breaks and we have y here, which is the successor of x. So we return that, and hence the code. But is it necessary that we always have a successor? So if this only this was the tree, then 13 would not have a successor. In this whole tree, 20 doesn't have a successor. Why? Because right child is null, so it will have no successor here. Then I try to find the code. I will have go to its parent. It is the right child of parent, so 20 will be greater than 18. Again I go to its parent. It is the 18 is the right child of 15, so I will not get any value, and now what happens, we hit a y which is null. Its parent will be null, so there is no parent here. Everything to the left will be less than 15 itself, so of course it will be less than 20, so right will have no successor. So what will happen, y becomes null, so again we are returning y which is null. It means it has no successor. Now the time complexity. So we saw the examples, either we were recursively moving up and maximum we can go till the height of the tree. Here we can go down from 15. If I want to find the successor, I will go here. So it will be of the size of the height of the tree, O of big O of h, where h is the height of the BST, which is equal to O log n to the base 2, and n is the number of nodes. So this tells how to find the successor of a given node, and helps a lot in many other tree operations. Okay, so I hope you understand this. If you like this video, please subscribe to my YouTube channel and tell it to your friends. Thanks a lot.